And bonjour. This is Bruno. I'm here with Darko. This is the Bruno and Darko show, and also known as the AI Biostat, etc. And today with Darko, we're going to talk about randomization and confounders. And as we were joking with our executive producer, Shahir, hi Shahir, thank you for the help. We realized that my pronunciation of confounders was very confusing, actually. He thought I wanted to get rid randomly of my co-founders. So it was very confounding, I have to admit. So, Darko, welcome to the show.
Thank you so much, Bruno. Really, really amazing to be here and discuss confounders and many other stuff. Of course, we're not founding anything on this podcast, but we will be discussing something which is pronounced very similarly, as you said, and it may confuse us, but during the show, I think we will explain all the differences.
I'm tone deaf. I think my hearing is getting as bad as my pronunciation. So thank you for bearing with me.
No, thank you, Bruno. Really, really amazing. I think this topic is super important because it's overlooked so much, and I think we will be discussing some angles which may be very interesting.
Let me set up the question. So, as a non-scientist, what I learned about clinical research, I understood that the core of clinical research, the essence nearly, okay, which leads to nearly most of the approved by the FDA. So the most evidence coming from clinical research is coming from randomization or randomized controlled trials, RCTs. And my understanding of what it is, and then you'll have to tell us why is it that we go through the trouble, which is extremely expensive, of randomizing. The core of randomization is that I'm a doctor, I'm treating patient, and every patient that comes to decide whether I treat it with drug A or drug B to compare the effect, right? Drug B could be placebo, could be standard of care. I don't decide essentially, right? It's randomized. It's absolutely randomized so that I cannot add bias to that selection. And we'll get to it in more detail. But the randomization is that the doctor doesn't decide who gets what drug, the two treatment we want to compare. It's randomized. And on top of that, sometimes it's blinded or double blinded, meaning the doctor doesn't even know which patient got what, and the patient doesn't know what they got either. Called double blinded. We'll talk about double blinded another time, maybe. But first, is my definition of randomization correct for a layperson?
Yes, it's absolutely correct, and that's exactly what what is done in randomized controlled trials. And as you said, RCTs, as we would use the abbreviation for them, are the core of majority of approved drugs. Now, there are a number of drugs, a smaller fraction, which is approved, maybe even in absence of RCTs, under special conditions. However, majority of those standard, let's call them, uh, large scale applications really come from RCTs, and there's a reason for that.
Now,
So
actually, just one thing about RCT. I mean, could you have a randomized trial that is not controlled? Or is it,
well,
again, it's a weird word because you need two arms. So is it that sometimes the second arm is not a control, it's a different intervention, and because of that we say RCT to get a three-letter acronym?
yeah, so that's exactly the scenario that's possible. We could have multiple arms in which neither is control, but usually we have the control, uh, because there is a specific part of the design that's called the counterfactual design, and that's why we need the control. We need to say, hey, something will happen if I have a treatment arm, but what would happen if I didn't have that treatment in that arm? And that's where the control comes in. But in theory, you're right. we could have different number of treatment arms without a control and use randomization there as well. And it would
Yes.
work perfectly. It would
In
work
a
the same way.
head-to-head trial, right? If you compare, I don't know, one
Yeah.
immuno-oncology drug versus another one, right? EP versus Nivo, which pharma never wants to do, of course, because who would be incentivized to do that? Maybe the NIH, the NCI. Okay, I understand. So that's an RCT, a randomized controlled trial, and nearly all of the randomized trials are also controlled, right?
Yes.
Okay.
Yes.
All right.
Mostly. Yes.
Okay, so that's how you randomized. The reverse of a randomized trials will be called a retrospective trial, a observational trial, a non-randomized trial. Is that right? These will be
Yes.
non-randomized. Okay.
Yes. And they would be lacking exactly, what makes the clinical trial very, very credible, very, very trustworthy. So, as you said before, with the funny term co-founders and confounders, they sound the same. So, for our audience, there is the N. N is the letter that actually differentiates them, and the confounders are actually these variables that could cause bias. They could affect our results. They could make the results not objective. So, if we have some other external variable compared to those variables that we want in the trial, those external variables, sometimes even internal ones, they can affect the results and cause bias in that. One of the sources of bias is what you mentioned is if doctors select patients based on some maybe some objective or subjective criteria, there's always a risk of causing bias within that selection. So what we do with randomization, we actually avoid, as you said, affecting the selection in any way. Now, what happens statistically? That's something that's going a level below that to the microscopic level. What's happening statistically is when we randomize, we are correcting for two types of bias. So for the bias that we know, so the variables that we can measure and that are in our data, but very important aspect of randomization is that it also corrects from the unknown types of bias. It shields from them. So that's one of the features that non-randomized trials don't have. In non-randomized trials or studies, you can correct for the variables that you have in the data, but it's very difficult to correct for what you don't know. Randomization actually corrects for what we don't know, and that's something very special about
I get it.
randomization.
I did not realize that at all before. By the way, just one word before we continue. To the audience, ask us, mostly Darko, because he's the one who knows, questions. Now, I know today we're talking mostly about biostat, not too much AI, although I might ask whether AI can help in this toward the end, Darko. But ask us question or put comments. We love any interactivity. So I understood something that genuinely I did not understand before, and the difference between known confounders, and unknown confounders. So let me repeat to make sure I understand, right? So let's say men and women. If the two arms if it's not randomized, and the doctor decides, and for some reason he always put the men on the drug and the women on the other drug, on the control, you could correct by adjusting the number of patients in each arm so that it's balanced statistically. Okay, so the known confounders could be addressed with, is that what's called propensity matching, or that's something else? A little bit,
Yes,
kind of
exactly. The propensity
propensity.
score matching. Yes.
Right. Propensity score matching. So you can do that, but there's a lot of unknown variable or unmeasured. Maybe how does a patient look? Does it look frail that it could support chemo? Right? That patient looks like right. He will have a tough time on chemo in a way that is subconscious for the doctor. So what we correct with randomization is a decision of the treating physician. Really, right? We replace a decision that is biased with an assignment that is random, right?
Correct. And
That's really what we do.
yeah, that's what we do. And by doing so, we actually introduce this shield from the bias. So I think it's a very good use of terms that you chose. There are things like confounders that can affect the results, and for some of them we know we can see them in the data and adjust them so that they're kind of equalized between the treatment and the control group. However, what do we do with everything we don't know? Human organism is so complex, and the ways that our organism responds to treatments is so complex. There are so many things that we maybe didn't measure, and that's why RCTs are the gold standard. They will protect the trial from those unknown sources of the bias as well. Now, there is one catch there, which is that for that randomization to work very well, we need to have enough patients so that the randomization is truly random. If we have just 20 patients in some study, randomization will not help us too much. We're never going to really achieve full randomness there. But if we have, 1,000 patients or 500 patients, then the randomization will really do its thing, and will introduce that shielding from all sources of, well, not all, but really vast majority of sources of bias.
Yes, and that can be measured whether or not randomization was sufficient based on the number of subject patients in a trial. Some people
Yes.
say subject, which is a technical term, but I recently heard that a lot of patients really don't like to be called subject, right? They're patients, and so I'm trying to also not use the word subject. I understand. Oh, side note and link to AI. I was reading on Twitter this morning, someone noticing that I don't know if that would happen when I do it. If you ask ChatGPT, okay, pick a random number from 1 to 100, right? It says, no, I cannot do it. No, it did it. 67. Oh, hold on a second. Oh, no, we got to do a parenthesis on talking about this because, well, so first, it did pick it. So I don't know why I saw. Maybe it was Gemini that cannot pick it. But what's interesting is that it picked 67. It picked 67. If I scroll up my feed, okay, in the same session, I ask, let me see if I can find it. Pick a random number. But I ask, do you know what I'm going to say? You have an idea?
Maybe ask why you chose that number.
No, like a couple of hours ago in the same session with ChatGPT, I asked, Shahir, do you know what I'm going to say?
I don't.
I
And
say,
hello to you.
could you clarify what the 6-7 meme is? Explain the 6-7 meme. Now, first, do the two of you know what the 6-7 meme is, or is it the older guy who knows what the 6-7 meme is?
I apologize. I am sorry. I'm probably not catching up.
Six
Me too.
seven
Me too.
6-7. You do or you don't know?
I don't. I don't.
Oh, you know the 6-7 meme. So I don't know how many days it's been trending, and I don't even want to try to explain the 6-7 meme. But anyway, it's a big meme. Some Altman said he might rename GPT-5, GPT-6, GPT-6-7. So that's why I checked it. So anyway, because I asked that question, so now it all makes sense.
Oh.
Okay, ChatGPT cannot generate a random number. It failed. It clearly wasn't random. It said 6-7 because I asked about the 6-7 meme a little bit earlier. That wasn't random. Imagine that's perfect to our topic, by the way, because it's confounding, right?
It's a confounder, yes?
It's a confounder. It actually
Yes.
was not random. It lied to me by saying it was random. It was not random. And he should have said, I cannot do it. Although I don't understand why we spent $500 billion and and ChatGPT cannot generate a random name from 1 to 100.
Yeah,
That's
that's very
incredible.
interesting. Yeah, it actually memorized your previous conversation,
Well,
I
it
assume.
remembered.
Yeah,
It got confused. It
and,
confounded.
yeah, and it was biased for the question you asked.
Yes,
For the question you ask requires to have zero memory. You randomly choose something.
that's right. And it
Yeah,
somehow thought that, oh, I'm going to use a previous conversation to guide that question,
yeah,
right?
yeah. I mean, OpenAI made the memory module to try to sort of, provide more context and, better experience for people. But there are situations like this where memory is actually a confounder. It's going to bias what you're asking. So
Right.
that's really an amazing example to
So
show.
you would think that randomly picking something is easy. Now, clearly, ChatGPT failed to that. And there's another story I like to tell you that humans are also terrible at randomizing mentally. There is that little game that psychologists did, and they ask, okay, Darko, pretend to flip a coin, right, head, tail, and write the result, but do it in your head. Pretend to be random, and then show me on a paper. And then I look at it. I'm going to tell you right away. Super easy. If you actually flipped a coin, or if you pretended to, because humans are terrible at faking randomization. And the trick is that humans will completely underestimate the number of times the same side, tail or head, will go in a row. We will do only string of 3 or 4, never 5, never 6. And it's obvious if you don't find a string of 5 or 6, human just made it up. Right? We should do
Yeah,
the experiment one time. But
yeah,
but
we should
humans
definitely.
are very bad, and computers should be so much better. But somehow, ChatGPT cannot do it.
Yeah, yeah.
Fascinating to me.
I wonder
Computers
why
are
humans
human.
uh, why humans are also biased in that example that you show with the head and tails. It may have something to do with the way our memory works, maybe, our short-term memory. So I think our own neural networks kind of switch between modes. And I remember this story from the time, and I still do actually play chess a little bit. So our brain virtually has a mode. So if I play chess on a bullet time chess, which is played very quickly, you know, the brain really switches to that quick mode. So
Yeah.
it notices patterns and associates things. So
Yes.
in that mode, it's very difficult to be, to provide that sequence of heads and tails randomly, as you said, because our brain is kind of hardwired to find patterns and not do
Yeah.
anything randomly. But in a different mode where you maybe play a chess for hours, your brain is in different mode, so then it can be more objective and less prone to finding patterns and actually calculate these patterns.
Yes. Yes.
I think maybe that's maybe one of the rare things where our brain is similar to ChatGPT and other large language
Mhm.
models.
Yeah. Well, we veered a little bit, but not completely from the topic of randomization. Actually, no, we stayed on topic. We just linked it to something AI related and human related. So that's the end of the time we have today, Darko. Any final words on randomization and confounders? And maybe in a future podcast, we'll talk about alternatives, right, to randomization.
Yeah, so I think that's the key. That's the key element of randomization is when we compare it to alternatives, why is it better? And I think we discussed today, one of the most important features, which is correcting for the unknown types of bias, and really looking forward to discussing the alternatives. There are some very interesting alternatives, and definitely we'll be
We
discussing
should do
those more.
one on known confounders. There's nothing to say about unknown confounders, but there's something to say about known confounders. So we can have one of the future
Yeah,
on. So
yeah, definitely.
thank you very much, Darko. Signing off. Au revoir.
Thank you so much, Bruno. Au revoir.